Stanford University.
Okay, well, welcome to lecture number 3 of Stanford CS 193P. This is spring quarter 2016, and today we are going to mostly talk about the layer under the UI. Okay, so we're going to talk about Swift, the language. We're going to talk about this foundation framework that lives on top of core services. So we're not going to be talking about the UI very much at all today. I do have a demo towards the end, so I will finish off the slides and then we'll do the demo to finish. Okay? All right, so first thing I want to talk about is optionals. Oh, by the way, everything I'm talking about today is in your reading assignments. Okay, the things I'm choosing to talk about today, I want to emphasize. Okay, these are things that you really, really want to understand. So if you see me mention it today and then you're reading it in the reading assignment, be sure to pay close attention, all right? So as we learned in the last lecture, optional is just an enum, okay? It's a generic type, kind of like array. It's got this little angle bracket T, which just means an optional can be an optional of any type, and we know that to be the case. We can have optional strings or optional, even optional optionals. We can have any kind of optional we want. And so it's an enum with two cases, the none case, which is the not set case, and then the sum case, which is the set case. And in the sum case, it has an associated value. And you learned all about enums last time, so this syntax should look completely familiar to you. So let's look at some of the little question mark, exclamation point stuff and what that means in terms of optional behind the scenes. So if you had a constant x, which was of type optional string, right, string question mark, and I set it to nil, then that's the same as saying that x equals optional angle bracket string dot none, right? Obviously. And same thing if I had an optional string that was set to hello, that would be the same as x equals optional angle bracket string dot sum with the associated value hello. Okay, everybody cool with that? And similarly, if I unwrap, if I said var y equals x unwrapped, that just means switch x, because we know that the way we unwrap optionals and get their associated value is with switch. So I'm going to switch on x. And in the case of sum, I'm going to do that let value thing, so I can grab the associated value, and then I'm just going to set y equal that value. In the case none, I'm going to crash. I'm going to raise an exception, okay, because that's what unwrapping an optional that's not set is supposed to do. It's supposed to crash. Okay? And of course, in the case where I'm doing if let, then I'm just going to switch on x. And I'm going to, in the case of sum, I'm going to grab that y, and then I'm just going to put some code, whatever my code is in there, and if let to happen there. And in the case none, I just break out of the switch. I do nothing. Okay? Sound good? All right, so that's optionals. Hopefully optional now should start feeling very, very comfortable to you, because as you've found out, it's everywhere in the API. Now, optionals have some more syntax. Okay, that question mark and exclamation point stuff, as you're seeing, is just syntactic sugar. It's just to make you're typing it in easier and look nicer. It has a little bit more syntactic sugar. One thing is that optionals can be chained. Okay, so this is the case where, for example, in our calculator, we have the display, and let's say we want to get the text out of the display, and then we want to send it another message like hash value, which strings understand this message hash value. How would we do that? Well, of course, we would say if let label equal display to unwrap the display, and then we'd say if let text equal the label's text to unwrap that, and then we would say let x equals the text hash value. Okay? So that's how we would unwrap it. Well, there's a lot easier way to do that, which is this. You just say display question mark dot text question mark dot hash value. Okay? So if you use question marks not when you're declaring the optional, but when you're actually using it, that basically means try and unwrap this, and if you can, then use that value to go to the next thing. If you can't, just return nil from this whole expression. Okay, this whole display question mark dot text question mark dot hash value, that whole expression will return nil if at any point any of these things that we're chaining unwrapped turns out to be nil. So if the display is nil, or if the display's text is nil, then this whole thing is going to be nil. So you see let x equal up there? What type do you think x is right there? Int, almost. Optional int, exactly. It has to be optional int because any of those things could fail and it would return nil, so it has to be able to take nil. So that would be an optional int because hash value returns an int. Okay? So you're definitely going to want to use this chaining. It really makes your code read beautifully, okay? And it starts to make optionals make a lot of sense why we use them so much. Okay, but there's more. Here's another optional syntax assure, which is question mark, okay? And this is basically providing a default value in case something is nil, okay? So let's say I have an optional string here, s, okay? I could say if s is not nil, then I'm going to set my display to be s, okay? So let's say I'm setting the display in my calculator, and I never want it to be nil. At worst, I want it to be just a space character. Because you might have noticed, some of you, when you're doing your homework, that if you put nil into a label, its size will go to 0. Okay? Because there's no text in there for it to have a natural size for. So sometimes you might want to have code like this, where if you want to put nothing in the display, you put a space character. So at least there's something in there for it to have a height. Okay? Otherwise, your display would keep disappearing if you kept setting it to nil. So we could do this: if s does not equal nil, then display equals s. That should be s exclamation point right there. Otherwise, display equals a space. Okay, well, a much simpler way to put that is with this defaulting operator, which is to say the display's text equals s, question mark, space. Okay, and that means if s is not nil, then unwrap it and use that value. Otherwise, use space. Got that? Everyone understand? I don't see any nodding heads on that one. Make sense? Okay. So this is, again, just a simple way to have a default value in case an optional is nil. All right, so let's talk about another thing, tuples. All right, tuples are a type, okay? In Swift, they're really, really cool. They're basically a way to build a type out of other types by grouping them, okay? And you can use it anywhere you can use a type. A tuple can be used anywhere types are valid, okay? So here's an example. I'm going to create x. Okay, this let x is a constant. Its type is a tuple with a string, int, and double. So even though tuple has the sound two in it, okay, it's not just two things. Any number of things can be in a tuple, okay? So x there is a tuple with string, int, and double. And I'm even setting it to a value, which is just parentheses, a string, an int, and a double, okay? Now, how do I get those values out of the tuple? Well, there's two ways to do it. One is to say let, and then three identifiers, these are basically three local variable names, equals x. Okay, and that's going to extract the three values and put them, assign them to word, number, and value, which are going to be local variables in this context. Okay, now if you tried to say let word comma number, close parentheses, equal x, the compiler will complain because word comma number can't match a string, int, double, tuple. Okay? So this particular syntax is just putting names on the things in the tuple so you can use them. So now you could print them out. Print word, print number, print value. Word would be of type string, number would be of type int, and value would be of type double. Okay, another way to do it is when you create the tuple, okay, you can name each of the things in the tuple. So here I'm letting x this time be w colon string, I colon int, v colon w. I'm giving the names w, I, and v to the things inside the tuple. I'm still assigning it just like I did in the version above. But now if I want to get at the values, I can just say x.w, x.i, and x.v to get at the tuple values. See the difference between those two cases? One, you're kind of naming it when you declare the tuple. The other one is you're taking a tuple that you got and you're just extracting the values. And you can mix them. For example, I could say let word num val equal x. Even though I defined it x to have w, I, and v, I could ignore the w, I, and v, and instead just use the syntax from the top, okay, and call it word num and val. Okay? So tuples are cool because you can return multiple values from a function with a tuple. Okay? So we know that return values are arrow and a type. Well, since a tuple can be a type, you can go arrow and a tuple and return values. Yeah. So the question, can you ignore in some of the values? Absolutely you can. If you use underbar. Underbar in Swift is the universal I'm ignoring this character. Okay, so you can put underbar in there. So yeah, so here I'm returning this tuple, weight, and height. Obviously, straightforward how we do that. So tuples are perfectly valid return values. Okay, so you can return multiple things from functions. All right, range. So range it's quite important actually in Swift. It's essentially just two endpoints, okay, of anything that can be represented consecutively, okay? So range, the type is generic, like array. So you can have a range of ints, you can have a range of indexes into something, or whatever. It really conceptually just has two things, a start index and a last index, okay, end index. An array's range, okay, if you wanted to get a range into an array, it would be a range of ints because an array is indexed by ints. So you would have a range of ints. In fact, there are methods in array where you can say, give me this range of yourself, and you specify it as a range. A string's range is not int. Okay, if you want a substring, you cannot use a range of ints. It's actually a range of string.index, which is a different type than int. And you're going to need to read all about that in the assignment. Okay, one of the sections in the assignment is indexing into arrays in the reading assignment, and you're going to want to understand that, okay? It's a little bit complicated. I'm not going to spend lecture time, but I'm pointing it out to you so that you go look at it. Okay? Now, there's special, just like with optionals, we got question marks and exclamation points. There's some special syntax for ranges, okay? Which is this ... and ... less than sign. You see them right here? Okay, the ... less than sign, okay? This means a range right here, okay, that goes from 2 to 3. This is a range that goes from 2 to 3, but does not include 3. Okay, so that would be just the number 2 right there. Okay, now see this for right here? For loops in Swift, all are for in like this. So if you wanted to go for I equals 1, 2, 10, I plus plus or whatever, you would do that with these ranges like this. Okay, for I in 27 to 104 or whatever. Okay, and you can make ranges that are more powerful than just direct ranges. I can't talk about that really time-wise, but again, check the documentation and you'll see how to do ranges, okay? So that's when you see that. Okay, let's talk about data structures in Swift. I'm talking about classes, structs, and enums. Okay, you've already seen them in the example. I'm going to talk about the similarities and the differences. So what's similar between class, struct, and enum? They're declared the same way, right? Just a keyword, the name of the thing, and then curly braces. Okay, I'll throw them like that way. They're also similar in that they can also have properties and functions. Okay, so you can have functions on them, and you can have properties. Enums cannot have stored properties. Only structs and classes can have stored properties, but enums can have computed properties. Okay, the storage of an enum, remember, is the cases. It's a discrete value thing, so it's the cases and their associated values. That's its storage. All right. They all can have initializers. Okay, we haven't talked much about initializers yet. We're going to get that today. And so they're all allowed to have initializers except enum. Okay, obviously enum doesn't need an initializer because you just set it to the discrete value with its associated values. Okay. All right. Differences. 1, inheritance. Okay, with classes you can inherit. Structs and enums you can't. Value types, I talked about this before, okay? Structs and enum are value types. They're passed around by value. Class is a reference type. You pass pointers to it around. It lives in the heap. Okay? Let's talk a little more about value versus reference. Value means that it's copied when passed as argument to a function. That's kind of obvious. But it also copies when you assign it to another variable. If I say var x equals y, if y is a value type, x will be a copy of y, a copy. So if y is an array, y might be an array, okay? And you say x equals y, and then you say x, append this thing. That thing will not be appended to y because x was a copy of y. You see what I'm talking about there? Okay? So that's a big difference with value semantics. Even just assigning them is a copy of them. A value semantic thing is immutable if it's assigned to a let variable. Okay, so if you have an array, okay, since that's value semantic because an array is a struct, if you assigned it to a let x equal an array, you cannot append things onto that array because it is immutable. Okay, same thing with a dictionary or whatever. Okay, remember that function parameters, all of them are constants, so of course you're copying them into there, you can't modify them. Because of the way copy semantics work, Swift makes you, when you do have a struct or an enum, you have to mark all functions that might change that thing, mutating functions, with the keyword mutating. So like mutating func whatever. Okay? If that function could change that struct. And the reason for that is when Swift copies it, it doesn't want to actually make a copy. Okay? It gets another pointer to it, but as soon as you try to mutate it, then it's going to have to copy it. You see? So it's kind of a performance enhancement. So anytime you have a struct that has a function that changes the values, any of the values of the struct, you have to put mutating in front so that Swift knows that you're doing that. Okay, reference types. Okay, this is what you're used to probably. Things are stored in the heap. You have a reference to them. Those references are counted automatically. That means there's no garbage collection in Swift. All right, there's no mark and sweep in the heap. Every single time you create a new pointer to something in the heap, Swift keeps track of that, and it keeps incrementing a count. And when that count goes down to 0, because maybe the last pointer that's pointing to it goes out of scope, or maybe you assign that last pointer to point to something else, nothing points to it, it immediately removes that from the heap. Okay, predictably removes it from the heap immediately. So it's very different than garbage collection, where garbage collection is kind of going on in the background, and it might collect a whole bunch of stuff in the heap all at once that's been sitting around for a while. This is predictable memory management, and it's all managed for you. Okay, there's only one way that you participate in that, which is the weak and strong, which I'll be talking about later. Okay. Let's see, constant pointers. Okay, if you have a constant pointer to a class, obviously it's a pointer, so you're still mutating it, right? It's not like a struct where if I say var y equals x and then I add something to y, it doesn't modify x. If I say var y equals x and it's their classes, then if I send a message to y, it's sending a message to x because they're the same thing, right? That same thing lives in the heap. There's no copying. So all let means is that pointer is not going to change. It doesn't mean what the pointer points to won't change. Okay? Obviously, so when you pass a pointer to a class as an argument, then it does not make a copy. It's just passing a pointer. Okay? Now, how do you know which to use? Struct versus class especially. Okay? Enum's pretty obvious, but struct versus class. Well, usually you're going to choose class over struct, okay, because this is object-oriented programming. You're used to doing it. That's going to be fine. Struct is going to be used for more fundamental types, okay, things like strings and doubles and ints and arrays and dictionaries, and also for drawing points, rectangles. You see what I'm saying? Smaller things that are self-contained, that it makes sense to copy by value, that you want the value semantic. That's going to be your primary reason for choosing struct, is you want value semantics when you're passing this thing around. Otherwise, you're going to choose classes. Okay? Anything big is almost certainly going to use a class. All right? Okay, on to methods. So now we're going to talk about the syntax of methods. Okay, I showed you this in class a little bit, but I'm going to talk about the full semantics here of it. So it's interesting about the naming of functions. So here's someone defining a method, and here is someone calling this method. Okay? Okay, so watch this colored stuff going on as I talk about these various things going on. So all parameters to functions have an internal name and an external name. Every single parameter. So here's the first parameter. Here's the second parameter. They both have an external name and an internal name. Okay? The external name comes first. The internal name comes second. The internal name is the name of the local variable that's going to be used inside your method. Right? So that's this one right here. Internal name shows up right before the colon. Okay, first and second. You can see how first and second are the names I use for those inside my function. Don't appear anywhere here. Notice first and second do not appear in the func bar call. Okay, because those are the internal names. The external name is what the caller uses when they call this method. Okay, so you can see bar down there. It says external first colon 1, 2, 3, external second colon 5.5, right? Okay, it's using the external names. First and second never appear, but first and second are still used in the implementation. Those are the internal names. Okay, you can put an underbar if you don't want callers to use an external name at all for a given parameter. Okay, so if you put underbar as the external name, then there will be no external parameter. So you see it says foo parentheses 1, 2, 3, not foo parentheses external first or anything. It's just nothing, 1, 2, 3. And in fact, this is the default for the first parameter. The first parameter defaults to underbar. You don't need to put an underbar there when you're creating a function. Just by default, an underbar will be put there for you. Okay? Now you could specify an external name for the first. It's legal. Okay, I'll show you that in a second. But by default, underbar is the external name for the first parameter only. All the other ones, okay, the default is the internal name. So if you don't have an external name, then it defaults to being the internal name. Got it? Okay. Any parameter's external name can be changed. Okay, you can change even a second one to be underbar so that a second one has no name. Okay, but don't do this. Okay, it's very anti-Swift to either remove the second parameter name or to add it back to the first. Adding to the first is probably less anti-Swift. There's probably some cases where that might actually make some sense. Removing them for subsequent ones is probably really bad. Okay, I don't think I've ever had to do that in my entire life of writing Swift. So, all right. Now, methods are obviously overridable. This is object-oriented programming, right? And the way you do it, you just put the word override in front of the func or var. Both properties and functions can be overridden, right? So you put override in there. It is possible to mark a method or a property final, in which case no one can subclass it. Okay? They won't be able to, subclass can't say override that thing. The compiler won't let them. Okay? You can also mark an entire class final, and then the whole thing is not subclassable. All right? Now, both types and instances can have methods and properties. What does that mean? So far in all the demos we've done, all you've seen is instance methods and instance properties. In other words, they are properties that you get from an instance of the thing. Okay, an instance of the calculator brain. Someone actually created a calculator brain in the heap, and you send it messages. Okay, those are instance messages, instance methods, and instance properties. But it is possible to have methods and properties on the type itself. So calculator brain, the type, can have functions. Okay, and here's what it looks like to call them. So here I have a little example. Here I have a var d, which is a double. Okay, and it's set to some value. So this d is an instance of a double. It is an actual double that has some value. All right, and here I'm checking by sending a message, an instance method right here, or probably a property actually, instance property on d, where I'm asking if its sign is the minus sign. I'm just making this up. I'm not sure, there's probably not even such a method on double, but that would be an instance property or method, and I would be sending it to d, which is an instance. If it does have a minus sign, I'm going to use a type property, or type function rather, of double here to change its probably absolute value, so it'll probably change its sign there. Okay, notice the syntax here, double.abs. Okay, this is the name of the function, abs. Okay, and I'm accessing it by saying double dot. So in other words, I'm putting the name of the class, not an instance of a class, not a variable of that class, but the actual name of the class, .abs. Okay, that is going to be defined, that abs will be defined like this, static func abs. This would be in the class double, and you put this word static, and that says that you don't send this to double instances, you send it to the double class by saying capital D double dot. Okay? Why do we have these things? Okay? These are usually utility functions, kind of global functions, but they're really strongly associated with a class, so we put them as class methods. Okay? That's what they're for mostly. Maybe you have a class method that creates shared instances of a class, okay? Something like that. We'll see a few of these. Once you start to see them in action, you'll start to understand. But I just want to make sure you understand that there is a difference between these two, and it's this static that makes the difference on declaration. Okay, that's also in the reading assignment. Make sure you read that carefully. In the homework assignment, I even say, be careful to read this carefully. All right, properties. Okay, properties are really cool in Swift. We're only just scratching the surface so far of what they can do. But one really cool thing about them is that you can observe changes to a property. Okay, and you do that by, here's your var. Okay, this is a stored property. This is not a computed property. It's stored. Okay, it stores an int. Its value is 42. But I'm putting the curly braces after it, not because I'm going to do get and set. I'm not computing it. But I'm going to add will set and or did set. Okay? So will set and did set, this is just code in here that's going to get called whenever this thing gets set. Okay? Before and after. Before it gets set, after it's been set. Okay? And inside there, new value is going to be the value it's going to be set to in will set. And old value is this value it used to have in did when you're executing in did set. Okay? So it's pretty cool. And you can do that for stored properties. You can do it for inherited properties, properties you inherit even. Okay? And you can do it for computed properties as well. Okay? Also here, this will be, one thing to note about this is these will sets and did sets, if you mutate a value type, they will get called. Okay, so operations here from our calculator brain, dictionary string operation, that is a value type. Dictionary is a value type, right? So if you add something to this dictionary, this will get called. Will set and did set will get called. Okay, that's not true if it's a reference type. Okay, if this property is a class and you change the class somehow, it can't detect that, so it doesn't do will set and did set. Okay, you have to change the pointer itself. All right? Okay. One very common thing to do in these will sets and did sets is update the UI. You've got a method in your controller, you set some value in controller that changes the way the UI would look, you ask your view to draw itself again. Okay? Very, very common. We're going to be doing that up the wazoo in the next lecture. Okay? All right, lazy initialization. So this is a little bit of a cheat code of Swift right here. You can declare vars to be lazily instantiated, which means that their value, this equals calculator brain, will not actually happen. That assignment will not happen until someone asks for the brain. Okay, if someone tries to send a message to this brain or get a property of this brain, then it's going to get initialized. So in other words, it's lazily instantiated, okay? And you can do it like that, okay? Just lazy var brain, calculator brain. You can do it down here, okay? Lazy var my property equals self.initialize my property. So I'm calling a method on myself to initialize one of my properties. Normally this would be illegal without the lazy. The reason this would be illegal without the lazy is that you cannot send any messages to yourself or access any of your properties until you're fully initialized. Okay? And this is part of your initialization, so it's a catch-22. You can't do it. But if you make this lazy, now you can, because it's not actually going to happen until after you're fully initialized and someone comes along and tries to access my property. Okay? No one can access my property before you're initialized anyway. So once you're fully initialized, someone accesses my property, lazy, boom. This method would get called to initialize you. Got it? And how about this one in the middle here? Some property of a given type equals a closure with open parentheses, close parentheses on the end. This just means initialize this by executing the code inside this closure. Okay, it's very similar to doing self.initialize my property, but you're putting the code in this closure instead of putting it in initialize my property, whatever that method is. Okay? Now, normally inside here, okay, if this weren't lazy, you would not be able to access self in here. Okay, because again, this is part of initialization. You can't do anything with self until you're fully initialized. So if you try to put self in here, the compiler will complain. But if you make it lazy, now you can access self in here. Got it? Call your own methods or whatever you want to do. Okay, so that's lazy. The reason this is kind of a cheat code is that this lazy business satisfies the requirement that all your vars have to be initialized. Okay, so even though these things are being initialized lazily, they're still being initialized for the purposes of that rule that all your vars have to be initialized. This kind of will often keep you from having to write an initializer. You won't need an init because it'll just lazily do it. Okay, that's why I say it's kind of a cheat code a little bit. Okay, one thing about lazy, they always have to be vars. There's no such thing as lazy let. Okay, lazy var only. Okay. You can also use laziness to get around some dependency issues. If you have one var, it depends on another. If you can make one of them lazy, then that'll be fine, right? Because the lazy one will call the one that gets pre-initialized, okay? All right. Let's talk about array. Okay, I'm not going to spend much time on this because array, you're used to array. You know what array is in other languages. It's pretty much the same in Swift. So I'm just going to try and cover the syntax a little bit. One thing is we've been using this kind of syntax for dictionary, right? Dictionary, angle, string, colon, operation. Remember that? This is the formal syntax for an array. But this square bracket, string, close square bracket is more informal, and it's the one we use. Okay, so as we go forward, we're going to use open square bracket string, close square bracket to mean the type array of string. Okay? And similarly for dictionary, open square bracket, key, colon, value, close square bracket. That is dictionary with keys of this and values of that type. Okay? Now, this is the type. So the open parentheses, close parentheses on the end just means I'm calling the initializer with no arguments. Same as up here. So don't get confused by that, okay? So that just means I'm initializing, I'm creating an instance of an array of string. Okay, that's what both of those mean. So if I can also create arrays and initialize them by just saying some variable like animals there, which is constant, let animals equal, open square bracket, list a bunch of things, close square bracket. That creates an array of those things. And notice I don't specify any type here. Why do I get away with that? What does Swift do? It infers type. So it would look at this and say, string, 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 string. All right, this is an array of string. Now, if I went giraffe, cow, 3, bird, then Swift would complain. Can't infer the type of that array because it's not all the same type. Okay? So it would infer it here. Now, notice this animals.append ostrich. If I put an ostrich in here, this will not compile. Okay, compiler will say no. That's because animals is let. It's a constant. So this is a constant array. It cannot be modified. If I put var right here, no problem. It would work. Okay? Now, if I say let animal equal animal sub 5, that's going to crash my program. Array index out of bounds, just like most programming systems do. It's one of the few cases that you can crash your program in Swift. We know unwrapping optionals is one. This is another one. If you array index out of bounds, it will crash. Okay? How do you enumerate array? I want to look at everything in array. Yeah, I could do for with a range, 0, dot, dot, the length of the array, right? 0, dot, dot, less than sign, length of the array. But that's not how you would do it. You would just say for animal in animals. Okay? This is going to loop through, and this local variable is going to be assigned each of the animals. Okay? That's how you enumerate an array. All right. Interesting array methods, okay? I'm not going to spend a lot of time on this slide, but I really want you to understand that these methods are here, okay? And you're going to want to use them. They will really clean up your code. They'll keep you from doing a lot of code that's like for, enumerate through my array, do this, if then, this, then, collected in another array, all that kind of stuff you can put in one-liners, okay? So what do these things do? These things use closures to operate on arrays. So filter, okay, is a method in array. You send it to it. You provide a closure which takes whatever type is in the array and returns a bool. And it just executes that closure on every single element of the array and includes the ones where you return true from your closure. And it excludes the ones you don't. Until filter returns a new array, which is only the things that match your closure. Okay? So here, for example, let big numbers equal this array. Dot filter, here's my closure, $0 is this thing, that's going to be for each of these, called on each of these. If $0 is greater than 20, I'm going to return true. So this returns an array, big numbers, that only has 47 and 118, because those are the only two things greater than 20. Got it? Okay, there's another one similar, which is map. Map takes your closure, and your closure converts each element in the array to something else. So if you had an array of ints and you wanted it to be an array of strings, you could do it with this. Okay? Map, closure, string, $0. Notice, by the way, no parentheses here. See, map. Okay, map takes an argument, which is a closure there, but I have no parentheses after map around the curly braces like I had up here with filter. I put this in here to show you that those parentheses are optional when a closure is the last argument to a function. Okay? When a closure is the last argument to the function, it can be outside of the function's parentheses, okay, and live on its own out here. Okay? Here's another function, okay, called reduce. this reduces the array to a single result. Okay, so this particular one, you can convince yourself of it later, it adds up the numbers. Okay, it just reduces, starts with 0, and for each one it takes the amount so far and adds it to the next thing in there, so it adds up the numbers. Notice this one has two arguments, an initial and a closure. Okay, see this closure here, an initial. And notice the closure also is still living outside of the parentheses. The first argument is inside the parentheses, but the closure is living outside. This one had no first argument, it only had the closure, so it has no parentheses here. This one does. Okay? This is called trailing closure syntax, and you almost always want to use it. It looks really cool, reads really nicely. Okay, dictionary. All right, so a dictionary, similar to array, it's just looking up keys and values. Again, we're going to use this more informal kind of syntax. Okay, open square bracket, string, colon, int, close square bracket means the type dictionary where the strings are keys and ints are values. All right, so if I had Pac-10 team rankings here and I had Stanford number 1, Cal number 10, and I let the, I guess it's Pac-12 now, I should update this, shouldn't I? So okay, Cal 12. And so if I say here, let ranking equal the Pac-10 rankings of Ohio State, that's obviously no Ohio State in the Pac-12. So the ranking here has to be an int question mark, right? It's an optional int. We already saw that in our calculator. Okay, anytime you dereference a dictionary, it's going to return an optional of whatever type is the dictionary's values are. Okay? The way you enumerate through a dictionary is using a tuple, okay? For key comma value in Pac-10 team rankings. Inside here, key is going to be the key, and here is going to be the value for each of the things in the dictionary. Okay, pretty cool. And again, you could put underbar here if you just wanted the keys, or underbar here if you just wanted the values. All right, string. String is a little complicated in Swift because it's full Unicode, and I mean full Unicode. All right, so it supports all kinds of languages, languages where one character might be many, many different codes. Okay, so characters are no longer single codes anymore. Okay, so that's why when you index into a string, you're not indexing by ints. You're indexing by indexes that know how to move along in a string past things like emojis that might have multiple codes. Okay? So you're going to want to read about this. I'm not going to cover it all in lecture here. But one interesting way to look at a string is by calling this string.characterView. Okay? If you call characterView on a string, you'll get the characters in what looks like an array of character. Okay, it looks like an array of characters. It's not actually an array of character. It's a character view. But it can be indexed with ints, okay, and you can get at the characters. So that's one way. Another way, you can actually create an array. One of the initializers that array will take is a string. Okay, and then it'll be an array of characters. Okay, not quite as efficient as this character view, but you could do it that way, especially a long string. You probably might not want to do that. Okay. But that's a little easier way to get at it. Otherwise, you have to understand what it says in the reading about string indexes, okay? String.index, that class, and how to use it to get things out of a string. Okay? There are a lot of other cool methods in string, though, like has prefix will tell you whether one string has the prefix of another string. You can capitalize and lowercase and uppercase these strings. You can even do sophisticated things like get me all the components in this string separated by this other string. So this is a method you send to a string. This might be a comma, let's say, and this right here, like this, and it will extract all the strings that are separated by comma. Okay, kind of fun. So make sure you familiarize yourself with a lot of the methods in string so that you don't waste your time writing this method which already exists. Okay, or similar methods like it. All right, other classes that are here that you have to think about. One is NSObject. This is the base class of all Objective-C classes. Okay? Now we know in Swift it doesn't have a mandatory base class like calculator brain, no superclass. Okay? Perfectly legal in Swift. But all Objective-C ones have to be subclasses of NSObject. Now, there are some APIs, they're fairly rare, and I'll tell you which ones they are when we get to them later in the quarter, that are Objective-C APIs, okay? And when you use them in Swift, you need to have a class that subclasses from NSObject. So in Swift, it's perfectly legal to subclass from NSObject. Not required, except for in these few cases I'm going to talk about later in the quarter, but legal, and it really won't hurt anything, so you could do it if you want. Some people just get in the habit of always subclassing from NSObject in Swift if they're not subclassing from something else, because why not, okay? And then their classes are always ready for whatever these weird old APIs are, okay? NSNumber, okay? In Objective-C, there's no such thing as, well, structs in Objective-C are not like structs in Swift. They're not this nice values type semantic thing, okay? Structs are more like C structs, okay? So double and int, string, array, dictionary. In Objective-C, these are classes, okay? Oh, sorry. Array and dictionary are classes. Double and int are C double and int, not even objects, okay? So that brings a problem in Objective-C. What if I want to put a bunch of numbers into an array? Okay, you can't do it because an array is an array of objects, and doubles and ints are C primitive types in Objective-C. So this class NSNumber is how you wrap a primitive type into an object, so you can put it in an array. Now in Swift we don't need that, because in Swift arrays and dictionaries will accept structs, and double and int is a struct. Okay, so this NSNumber not necessary for that. Okay? Now, there are iOS APIs that take, for example, arrays of ints. And in Objective-C, they're going to be arrays of NSNumber, and in Swift, they're going to be Swift arrays of Swift ints. And you might ask, how is that ever going to work? Because you're talking about a struct filled with structs versus an array class filled with these NSNumber classes. Well, the answer is those things, array, dictionary, then int double, and NSNumber are all bridged magically and automatically. Okay? As you call functions that require one to be one way or the other, it just automatically works. Okay? There's a lot of magic going on in Objective-C runtime to make that work. Okay? And we're going to take advantage of that bridging in a couple of slides here. NSDate, really important class to know about. If you want to put a date in your UI, you need to be very careful because dates are represented in a different way all over the earth. Okay? And date class knows all about those ways, and it has a lot of companion classes like NSCalendar, NSDateFormatter, NSDateComponents to help you put dates on screen in a way that's going to work when you translate your app to Chinese. Okay? So NSDate is an important class to get familiar with and understand what it can do. Okay? If you're ever going to put a date in your UI, you're going to need to know about NSDate. NSDate can also tell you the current date and time. All right, NSData, that's a bag of bits, okay? Just unstructured bag of bits. We use it to pass things around, sometimes over the network, like image data, things like that. It's pretty self-explanatory. Bag of bits doesn't have a lot of methods on it. It's basically just give me the bits, and here are some bits. Okay, now let's talk about initialization. I'm going to kind of blast through this pretty quick. There's a really good explanation of this in your homework, in your reading assignment for this coming week. But I'm going to try and give you the 50,000-foot overview of it quickly so that you kind of have an idea what's going on as you go and read that very detailed description. Okay? So when is an init method needed? We're talking about initializing structs and classes. Okay? They're not needed that often because, of course, we can say equal something in the var. We could use those lazy instantiation things to get around it. Properties might be optionals, and they can just start off being not set. So there's a lot of reasons you don't need an init. Okay? And frankly, most people try to design their classes and structs so they don't need an init. Okay? So you can just create them with an init with no arguments, right, which you get for free. Or in the struct case, maybe you just do what we did in the demo where you just init it with the values of all the things in the struct, okay? But sometimes you might find yourself needing an init because you just can't initialize things using those mechanisms, all right? Now, you do get some free inits, okay? We know about in classes you get the init with no arguments for free. That's how Calculator Brain got an init, so we could create one. And we also know that structs have a free initializer that lets you initialize all of its vars. Now, one thing to know about both of those cases is that you if you start providing your own initializers, then you stop getting the free one. Okay? If you provide even one initializer for your struct, you no longer get this free one, the one that does both. Okay? All right, what can you do inside of init? What is legal to do? You can set any property's value, even ones that already have default values, ones that you said equal something. You can reset them to something else if you want. You can set any property's value, okay? You can even set constant properties, okay? So if you have let something, so you have a constant in your class, like a constant instance variable basically, you can set that in, even though it's let, you can set it in the initializer. Okay, constant properties are fairly rare. You know, why would you have something that's constant? You might, though. You might have something that is determined at initialization and then never changes, okay? You can call other init methods from your init. You can call one other init method from an init, okay? And you can call superclass inits. Okay, you can call your superclasses initializers. But there are rules for calling inits, and they're rather complicated. And I'm going to go through them quick, and you're going to read the documentation. It's going to give you all the details, okay? So there are requirements inside of init, things you must do. The previous slide was things you are allowed to do. Here's the things you must do, okay? By the time any init is done, okay, by the time the init is finished, all properties must have values. We know this, right? In Swift, by the time initialization is done, all properties have to have values. And again, optionals must have a value too, but it could be the value not set. That's fine. Okay? Now, there are two types of init methods in a class: convenience methods and convenience initializers and designated initializers. Designated initializers are not marked with convenience, the word convenience. Okay? Convenience initializers say convenience init, whatever, okay, in their declaration. A designated initializer must and can only call a designated initializer in its superclass, its immediate superclass. Okay, so a designated initializer can't call a convenience initializer in its superclass, and it can't call a convenience initializer in its own class. It must call a superclass's designated initializer. Okay, you must initialize all the properties that you introduce in your class before calling a superclass's init. Okay, so by the time you call super init to let your superclass initialize, you must have all your properties initialized. All right? You must call a superclass's init before you can touch any of your superclass's properties. See the order there? You do yours, call a super, now you can touch theirs. Okay, that makes sense. You got to let them initialize theirs before you can touch it, and you want yours initialized before they come along start doing their stuff. A convenience initializer must and can only call an init, either convenience or designated, in its own class. Cannot call super. Okay, a convenience initializer cannot call a super initializer. A convenience initializer must call that init before it can set any property values, its own or its superclasses. Okay, in other words, it must let a designated initializer initialize your own properties first, and that thing is going to call a super, and it's going to initialize its. So by the time a convenience initializer gets back from the init, all the property values will be set, and it can reset them to something else. Okay? It's just a convenience. Calling other inits has to be complete before you can access any properties, I'm talking about, not set, access any properties or methods in yourself. So you can't say self.anything, you can't access any of the properties or method in yourself until you're fully initialized. Okay? So you'll have to have called the other inits first. Yeah?
If you're building an inherited class, why would you ever use convenience inits?
So the question is, why would I ever use a convenience init? The answer is, I have a reasonable default for some of the arguments to a designated initializer, and it's actually possible to default things in Swift. You can basically say equal something, but let's say you want to default it to some calculated value, maybe based on the other arguments. A convenience initializer you could create would have fewer arguments and then turn around and call the designated one. Okay? It's truly for convenience. That's all these are for. Phew is right. Okay, there's a lot of rules there, and it's a lot to think about. And when you start writing your own initializers, you're going to bump up against these all the time. You're like, oh, I can't access that one until I do. Oh yeah, I got to call super. And okay, believe me. So try to stay away from doing your own inits. This is my advice to you. Okay, inheriting init. Now, if you don't implement any designated inits, you'll inherit all of your superclasses designated inits. But if you implement even one designated init, you don't get any of your superclasses designated initializers. Okay? If you override all of your superclasses designated inits or don't implement any of them, then you will inherit all of the convenience initializers from your superclass. Okay? In other words, the convenience initializers in your superclass are all kind of dependent on the designated initializers in your superclass being sensible and making sense together. So you either have to get them all by overriding them all or by overriding none of them for the convenience ones you inherit to make sense. Okay? If you implement no inits, you get all of your superclasses inits, convenience and designated. Okay? Any init that you inherit by these rules counts on the previous slide. Right? The previous slide says things like you have to, a convenience has to call a designated in your own class, blah, blah, blah. Well, if you inherit it, then it is in your own class. Okay? So chew on that. Okay? Required init, different topic. It is possible to mark an init with the keyword required. That means that a subclass must implement this init. Okay? It is not optional for it, it must. And it can inherit it if it follows these rules above. Okay? But it must implement it, it's required. Okay? UI view, for example, which we're going to do on Wednesday, it has a required init. Okay? And we're going to see that. All right, failable initializers. It is possible for a init to fail. We saw this, double. If you pass a string to the initializer, if double has an initializer, it takes a string. If you pass a string that's not a double, then it will fail and return nil. Okay, so failable initializers cause optional versions of the thing to be returned, and you specify them with this little question mark. If you put init question mark in there, that turns this initializer into the kind of initializer that will return an optional of this class, whatever it is. Okay? And to fail, you just return nil. Inside this initializer, if something goes wrong, return nil, and nil will come back to whoever's trying to get this thing. Make sense? Okay? Failable initializers are pretty rare. Images, for example, UI image, image named. If it can't find an image with this name, it returns nil. Okay? So that's why this image right here, let image, this image is an optional UI image. And we probably use if let here, if we can let this image equal a UI image named foo, then whatever. Okay? All right, creating objects. All right, usually you create an object by calling its initializer with the appropriate arguments using the type name. So calculator brain, you've seen that. Complicated object with a bunch of arguments to create it, or here's let z equals the type array of string initializer. Okay, that creates an empty array of string. It's constant, so it's going to be empty forever. Okay? But sometimes other objects will create objects for you. They can call a method and it'll create an object for you, give it to you, right? But when you're creating objects from scratch, this is the syntax you're using. You're used to that, right? No questions about that? It's a kind of obvious slide. Okay, now any object, a little more complicated here. Any object is a special type. Okay, it's actually a protocol, but we haven't talked about it yet. But anyway, it's a special type. You can think of it as a type. Protocols are types, I guess. It is used commonly, or used to be, for compatibility with Objective-C APIs, because Objective-C, for those of you who are trying to learn some Objective-C along the way here, Objective-C has a very important type called ID, okay, the type ID, which means pointer to an object of unknown class. Okay? So that's a very open-ended type, okay? Swift doesn't do things that way. Swift is strongly typed, okay? It infers types, but it's strongly typed. However, Swift has to work with all those iOS APIs, so it introduced this type called AnyObject. So AnyObject in Swift means a pointer to an object of unknown class, okay? It only works for objects, for classes, not for structs. So it means the same thing as Objective-C. In iOS 9, they fixed Objective-C, so it has almost none of these. Okay? There's still a few, but very, very few. So nowadays, it's more used as an opaque type. Okay? When you want to have a pointer to an object, and you're not sure what it is, or you don't want anyone to know what it is. Okay? So let's talk about how we can do this. Okay, so classes only, no structs. There is another type, by the way, in Swift called any, which is anything. Could be a struct, could be a class, anything. In fact, this class we will never use any. Okay, you probably never want to use it. It's in there, I think, for just language completeness, but I can't even think of a good explanation of why you would want to use it. So we're not even going to talk about any. But we are going to talk about any object, okay? So where will you see any object? You'll sometimes see it in a method where one of the arguments truly can be more than one different kinds of class, okay? For example, you'll see on Wednesday prepare for segue, which is a thing that prepares for transitions from one MVC to another. Okay, we're going to have multiple MVCs someday. We're going to want to transition from one to the other. Prepare for segue prepares for that transition. Well, the sender, in other words, the object that initiated the transition, could be lots of different kinds of objects. It might be a button you clicked on. It might be a row in a table. It might be some custom code inside of your controller, okay? So this sender has to be any object, okay? Because we don't know what it is. We don't know if it's a button or a table row or what it is. So any object, okay? So this is a case where here's an object. It could be many things. We don't know what it is, so we have to type this as any object, okay? Another example of that is touch digit. If we hadn't, when we controlled dragged, remember we changed it from any object to UI button? Okay? If we hadn't done that, it would have created touch digit with sender any object, and then touch digit could have been sent by a UI button or maybe by a UI slider, okay? Or something else. And we didn't do that because inside touch digit we wanted sender to be a UI button so we could send it current title and other button things. But it could have been any object. All right? So another use for any object is when you want to return essentially a cookie. Okay? A cookie is something you give back where you're giving it to someone. They don't know what's inside of it. You're not going to tell them. The only thing they can do is give it back to you. Okay? So the cookie just saves some state, or remember something, and you can give it back. So like browsers have cookies, right? You go visit a browser site. The site stores some stuff about itself and about you in their cookie. When you go away and come back to that site, it looks in the cookie and it can interpret it. Okay? But it gives the cookie to the browser. The browser has no idea what's in there. Okay? It's opaque. It's any object as far as the browser is concerned. All right? So how do we use a variable type any object when we don't know what the heck it is? Okay? And the answer is we have to convert it to a type that we do know what it is. Okay? Now, this conversion might not be possible, right? Because that thing might not be of that type when we try to convert it. So we use this as keyword in Swift to try to convert it to the other type. Okay? In other words, try to treat that any object as something else, optionally. So this returns an optional. Okay? We usually use it with if let, this as thing, because it returns an optional, right? So if I have this local variable here, AO, which is an any object, and I've assigned it to something, some class, I don't know what it is, okay? But I want to try and use AO as if it were of class some class. Okay, AO might be of some class, and I'm going to see if it is, and if it is, I'm going to use it as some class. I say if I can let foo equal AO as some class, then in here, there's going to be a local variable foo, which is not going to be any object. It's going to be of type some class. Got it? So it's just that simple. We're essentially casting, if you want to use that terminology, casting any object to be some class, conditionally. Okay? So that's how we use something of any object. Either that, or we don't know what's in there and we just pass it around. Okay? We just pass it around to people who know what to do with it, and we don't know what to do with it if it's a cookie. Okay? So what would code look like, let's say, on touch digit? If we had touch digit and we had any object instead, we'd probably say, if we can let sending button equal this sender as a UI button, then we'll treat it as a button, get its current title, and go. Otherwise, else, if we can let sending slider equal the sender as a UI slider, then we'll let the digit equal the ascending slider's value, which is a double, we'll convert it to an int, and we'll convert that to a string. Okay? That's how we get the digit. But you see how we're doing kind of if, let, else with this optional thing? That's how we would use that any object. All right. Another use of any object is property lists. Okay? So property lists are essentially any combination of array, dictionary, string, double, int, NSData, and NSDate. Okay? If you build any data structure out of only those classes, you got a property list. So it's just a word. It's just a term we use to mean that. Okay? That's what it means. And you might be like, oh, wait a second. Array, any object has to be a class. It can't be a struct. But string, array, dictionary, double, those are structs. So how could these ever be in a property list? How could it ever be in any object? And the answer is the bridging. Okay? We got this automatic bridging to Objective-C. Okay? It automatically treats them like NS dictionary, NS array, NS number, which are all classes, and it allows them to be any object. Okay? Now, these property lists are plastered around blindly. The people who are looking in them are only knowing that they're dictionaries and arrays of strings and dates and stuff. They don't know anything about what that data means. Okay? They're just being passed around. So let's look at an API in iOS that uses a property list to understand it better. It's called NSUserDefaults. What NSUserDefaults does is it takes a property list and makes it persistent on disk. So that when your app quits and runs again and you look it up again, it's there. So it's basically a database of property lists, a database of structures with dictionaries, arrays, strings, dates. Okay? That's what it is. It's a small database, so don't use it for big things. You wouldn't want to store like a dictionary of the entire English language in there. It's for small things like settings and things like that. The API on it is very simple. You just say set object property list here for key string, and then you can look it up and get the property list back. So here you can see how you're just passing it around. You're storing it as a cookie. NSUserDefaults has no idea what's inside there. It just knows it's only arrays, dictionaries, strings, ints, etc. Okay? It can also restore smaller things, like you can say set double, and it'll make a little property list out of a double, because a double by itself is a property list, right? Because it's one of those classes, okay? Just like array is. How do you use user defaults? You create a shared one using this class or type method, NSUserDefaults, standard user defaults. This gives you this shared instance of user defaults. And then you just say to it, get me a certain property list, write this property list out. The changes you make will automatically be saved eventually, but if you want to force them to be saved on disk, you can do synchronize, which returns a bool, which we almost always ignore because it's not clear what to do if it fails. It would probably only fail if your disk were full. I'm not sure what you're going to do at that point. But anyway, we usually ignore that return value. Okay? Another example of property list might be in our calculator brain. And I'm going to show you a demo of this really quick here, which is what if we wanted to get the program that's in the calculator? Right now, our calculator could be programmed by saying 5 times 4 times 3 equals. That's put a program in the calculator, right? 5 times 4 times 3. It's kind of a simple program. It'd be cool if we could get that program, and the person who got it doesn't know anything about our internal data structure, so it's any object to them. And then later, they could come back to a calculator brain and say, oh, run this program that you gave me earlier. You see? So we use any object as kind of this opaque program. Okay? Now, this doesn't seem very valuable right now, but it's going to be real valuable in assignment 2 when you're going to add variables to your calculator. You're going to be able to say 3 times x times 5 equals. Okay, where x is a variable. And then you can run this, then you get this program using this code I'm going to show you here, a property list. And then later they can set the variable x and run it again. Maybe set the x to something else and run the program again and again and again, you see? So this would be a good use of any object because the calculator brain doesn't want to give away its internal data structure for how it represents a program. But it's happy to let someone have the program and give it to them later, and they'll run it again later. Make sense? See why we want it? Now, why would we make it a property list? Because it would be nice to store it in user defaults. Right? I got a program, I'm going to put it in user defaults. Next time my program runs, I can pull it out and ask a calculator brain to run it. You see? It's just more flexible to be a property list. So that's what we're going to do. We're going to create a var called program in our calculator brain. It's going to be gettable and settable. When you get it, it gets the current program that the calculator brain has just run. And when you set it, it runs the program. Okay? All right, so I'm going to do that as the demo. I'm going to finish off the slides here first. One thing about this casting, you can cast other things besides any object. Okay? So for example, you can look at this slide later, but you could have a class that's a subclass of another class. Okay? And you can try and cast using as to get the subclass. You're not sure whether it's a subclass, but you can cast, and as will tell you whether it is. Okay? In this case, for example, if I have view controller, the base class of our view controller, we can't say VC display value because this is a calculator view controller thing. But if I went and as'd it, okay, if I took this VC and as'd it to calculator view controller, now I could use display value. Okay, so as is for more than just any object. Okay, and yes, you can force with as exclamation point. It'll crash if you can't do it. Assertions I'm not going to talk about because we talked about that in the debugging section. You can look at the slide or the reading assignment to find out more about assert. And that's it. So coming up on Wednesday, I'm going to start talking about custom drawing. On Friday, we don't have a section for this week. And next Monday, I'm going to start talking about gestures, multi-touch gestures, okay, pinches and swipes and stuff, leading up to your assignment 3, which is you're going to be doing a lot of drawing and multiple MVCs and all that stuff. Your assignment this week is going to be the variables thing. Okay? All right, so let's do that program var. Okay? I'm just going to go back to our calculator here. All right, and leave off exactly where we were. All right, so here's my controller right here. I'm not going to change my controller to do this. This is purely a brain thing. Okay, here's my brain, calculator brain. So I'm going to add a new var. Let's put it, I don't know, down here. Okay, it's going to be called program. It's any object. Now I'm going to make it be any object, but I'm also going to make it be a property list because it's more useful. People can put it in as user defaults or whatever. So I'm going to use a cool Swift thing called type alias. Type alias lets you create a type, a name type, that's exactly the same as some other type. So I'm going to create a type called property list, which equals any object. So property list is now a type in Swift. It's exactly the same thing as any object. Now why would I create this? That's because I'm going to change this to say property list. So I'm going to make the type of my program be property list. This tells anyone using my program that, yeah, it's any object, but it's also a property list. Okay? This is documentation. I'm essentially documenting here that this any object is property list. I could have also just put some comments in my code that says it is, but it's kind of really hammers home the point here that this is a property list, okay? Now I'm going to have my program here be computed, okay? So I'm going to do the get set thing, right? And so now I need to have my program internally. I need internally store my program. So I'm actually going to go up to the top and create another private var, which is my internal program. And so I have to think about how I'm going to store my program, you know, all the operands and operations internally. And I'm just going to store it to show you the power of any object. I'm going to store it as an array of any object. Okay? And the objects in that array are going to be a double if it's an operand or a string if it's an operation. So I'm going to have an array that has a mix of doubles and strings. Okay? And that's going to store my program. I'm just going to put operands in as doubles and then put the operations as strings. So that's another power of any object here. So how do I implement my internal program? Real simple, okay? When I set an operand, I'm just going to tell my internal program, append that operand. Oops. Okay, now normally this is any object. Operand is a double, that's a struct. That normally wouldn't work, but the bridging, the Objective-C bridging, will make this work. Okay, I told you everywhere in the UI where you have this compatibility, it's going to automatically bridge. I don't have to do anything or say anything. It just automatically always bridges when necessary. Okay, similar down here in my operation. When someone performs an operation, I'm just going to tell my internal program, append the symbol for this operation. Okay, that's a string. Again, a struct, but it's automatically bridged to NS string, and thus can be in any object. Okay, that's it. That's the entire implementation of my internal program. I'm just remembering every operand and operation. So now I'm just going to return that internal program here okay, to be the program. Now you might be freaking out. Whoa, you're returning your internal data structure here to a public caller. But what kind of type is an array? A value type. And what happens when you return a value type? It gets copied. Okay, so I'm not returning a pointer to my internal data structure here. I'm returning a copy. Okay, that's again the cool thing about having these things be value types. All right, so now we have to do the set. So someone can now get my program and they can give it back to me later and I have to run it. Okay, so how am I going to do that? Well, when someone sets my program, first I'm going to clear whatever's in my program. So you guys probably implemented something like this for your homework, but I'm going to clear my accumulator. I'm going to say that I have no pending binary operation, and I'm going to clear my internal program that I currently have out. Actually, I'll just remove all items from my internal program, okay? So that's clear because I'm running a new program, so I'm going to clear myself out. All right, make sense? Now I'm just going to say if the program they gave me is an array of operands and operations, so I'm going to say if I can let array of ops equal this new value that they just gave me as an array of any object, which it has to be. If it's not that, I can just ignore this. Someone gave me a program which was not one that I gave out, so I'm ignoring it because it's got to be an array of any object or I can't figure out what it is. So if it is, now I'm just going to go look through at all the ops in there, all the operations and operands. Okay, an array of ops. Okay, that's how we loop through an array, right? For in. And for each one, I'm going to check and see what it is. Now, what type, if I could alt-click on this, what type is this going to be? Any object, exactly. See? Any object. So I can't do anything with any object, so I have to try and see if I can make it something else. So I'm going to first try and make it be an operand by saying op as a double. Okay? So if I get to here, then this op, the next thing I looked in the array, was a double. Excellent. Then I can just say set operand to be that operand. Okay, because I'm running the program. So I'm just going to replay, basically, my operands and operations. Otherwise, if I can let, let's say, operation equal the op as a string, okay, then I'm going to perform that operation. Okay? Done. Okay, very simple. I've done it. Now, you're going to have to really make sure you understand this because you need to enhance this for your assignment number 2 because you're going to have variables you're going to have to deal with here too. You're going to have variables in your program, not just operands and operations. Now, let's see this thing in action. We've got this code. We want to make sure it works. So let's put something in our UI that actually checks this program business. So I'm going to go back to my storyboard. I'm going to steal a couple of buttons here. I'm going to make this be the save button and this be the restore button. So I'm going to have the save button save the program, and then I'm going to have the restore button restore the program. Okay? So you can see how it would look like to use that. So these are not operation buttons anymore, so I'm going to disconnect using right click. All these perform operations. Okay? Then I'm going to wire these up. Let's make some room. We'll wire them up down here. All right, so I'm going to wire up save first. Put it right here. I'll call it save. It's an action. It doesn't need an argument. I don't need the sender this time. This is the first time we've seen where we don't need the sender. Okay, at least the first time not in your homework. And here's restore. And restore is also an action. And it doesn't need an argument either. Here we go. There's save and restore. Okay, how am I going to implement this? Well, I need the saved program, so I'm going to have a saved program. Its type could be any object, but I'm actually going to have it be calculator brain.property list. Just to be clear to myself, this is a property list, and if I wanted to save this into NSUser defaults, I could, okay? But I'm not going to, but I could. All right, so how do I save? Oh, and I'm going to make this optional because, of course, I might not have hit save yet. So it's going to start out nil. As soon as I hit save, it's going to have a value. All right, so how do I save? Well, I'm just going to say that this saved program equals the calculator brains program. Okay, that's going to store it in there. Really good, easy. How about restore? Okay, well, if I have a saved program, okay, if it doesn't equal nil, then I'm just going to set the brains program equal to the saved program. Okay, I have to unwrap it because it's an optional. And then I better update my display value now because the brain's going to have a different result. It's got a new program, it's going to have a different result. Got it? Okay, now this code, you don't need this in your assignment. I'm only put this here just to demonstrate program. You will need the other code in Calculator Brain, but you will not need this code. Okay, let's go ahead and run this. All right, here we go. Make this a little bigger. All right, let's rotate so that our restore button looks better. All right, here we go. So let's put a program in here. 4 times 5 plus 1 equals. Okay, that's 21. Okay, let's save that program. Now let's do pi square root. Okay, that's good. Plus 8 equals, something like that. Now let's restore. What should happen to our display when I restore? 21, because it's going to rerun that program. And sure enough, there it is. Okay, 14 divided by 7 equals restore. Okay, we've run that program, and that's the result in there, so we can say times 2 equals. Okay, we could save it again. Okay, 47 divide 8 equals, and now when we restore, we'll get 42, which is the meaning of life, the universe, and everything. And so we're done. Okay, so get that program code into your app. Okay, you'll need to add that to your assignment 1. And then I will be publishing. I might actually publish assignment 2 before Wednesday. Okay, it goes out on Wednesday, due the next Wednesday. But for those of you who want to start a little early, because you know everything you need to know now to do assignment 2 as well. Okay, so I'll probably publish that earlier, maybe tomorrow.
For more, please visit us at stanford.edu.